All right, welcome back. Number 11 will not be on the final, so I am going to skip it. However, if you would like to see it done, I will do it for you. All right, number 12, an infinite series has a1 equals 6 and a sum of 9. Find r. So this is geometric. So the formula we're using is s equals a1 over 1 minus r. Now you all should know this really well from that polynomial quiz. Oh no, sorry, not the polynomial quiz. It was the one with the first unit test where everybody keeps coming in to make a correction on this because they still don't understand. So an infinite series has a sum that converges of 9. So the sum is 9, a1 is 6, and we are looking for r, 1 minus r. This is so easy, guys. Look, s equals 9 equals a1, 6 over 1 minus r. We're just solving for r. So we're going to multiply both sides by 1 minus r because we need it out of the denominator. Don't forget to distribute through. So that gives me that 9 minus 9r is equal to 6. And then I would subtract 6 from both, subtract 9, my bad, from both sides. And I get negative 9r equals negative 3. Divide by negative 9. R equals 1 over 3. 3 over 9, right? But we can divide the top and bottom by 3. So 1/3. Done. All right, next let's flip it over to number 13. It says write a cubic polynomial in standard form with roots. Roots are mean x equals, right? Solutions at 2, -4, and 0. So number 13, we have x equals 2, x equals -4, and x equals 0. So what we need to think about is what are the factors that created these? All right, so to get these solutions, remember that we would have had factors that we had set equal to 0, meaning I want to make these equal to 0. So I have x minus 2 equals 0, x plus 4 equals 0, and x equals 0. So my three factors are this one, and this one. So x minus 2, and x plus 4. Now, to create my polynomial, I need to multiply these back out. So I'm going to multiply x minus 2 times x plus 4. That's x squared. Whoops, sorry. Plus 4x minus 2x and minus 8. Combine like terms. X squared plus 2x minus 8. All right, don't forget we have to multiply by x still. So I'm going to bring my x back down. And this gives me x cubed plus 2x squared minus 8x. And that is my polynomial. Now they might use y equals, they might use f of x. I'm going to put y equals, it was x cubed plus 2x squared minus 8x. All right, number 14, use long division to find the quotient of these and write it in this form. All right, so using long division, I have 2x plus 3, and I'm going to divide that into 6x to the 4th plus 13x cubed minus 6x squared plus 8x minus 3. All right, I want you to make sure that you're not missing any terms. You have x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and no x. So you're not missing any terms, you're good. So you should be thinking, what would I need to multiply 2x by to get 6x to the 4th? Well, x times what is x to the 4th? X cubed. 2 times what is 6? 3. And then you're multiplying 3 to 2x, 3x cubed to 2x. So that's 6x to the 4th. Remember, these will match. And then multiply these two together, you get 9x cubed. This is where we do the switch. and those cancel. So 13 minus 9 is 4x cubed. And bring down your next term of negative 6x squared. So now you're thinking, what do you need to multiply 2x by to get 4x cubed? 2 times 2 is 4. X times x to the second will be x to the third. Multiply both terms. That's 4x squared. Multiply 2 times 3. That's, excuse me, 6x. Oh, sorry, x cubed. My bad. Right here, x cubed. 6x squared. And again, switch. And this gives me negative 12x squared. Bring down my next term. And that gives me 2 times what is negative 12x squared, which would be negative 6. And then x times x will give me an x squared. So that'd be negative 12x squared. Multiply here, we get negative 18x. Switch. That's 26x. And bring down your last term of negative 3. What would you multiply by 2 by to get 26? It's 13. And 13 times 2x is 26x. 13 times 3 is 39. And then, of course, we do the switch. And that's negative 42. And our remainder, there's no more terms to bring down, must be negative 42. And we place that over our divisor, 2x plus 3. And so our quotient is 3x cubed plus 2x squared minus 6x plus 13 minus 42 over 2x plus 3. All right, we're going to find the roots of this polynomial. So it's a degree 4 polynomial, so it should have 4 roots. Okay, so in order to, we could try to factor, but there's 1, 2, 3, 4, 5 terms, so we can't factor. So we could only use the rational roots theorem. The rational roots theorem is p to q, right? So all of our values of p come from right there, negative 2. So all the ways to multiply to get negative 2 are plus minus 1 and plus minus 2. And then q's come from right here, which is plus minus 1. So all the possible p's over q's is 1 over 1, which is 1, and 2 over 1, which is 2. Now that we've identified the possible rational roots, now we're going to use synthetic division. Our p over q is plus minus 1 and plus minus 2. So we're going to use synthetic division. I'm going to pick, I'll pick 2. And when I use synthetic division, remember I only use the coefficients, and then you do have to check to make sure no terms are missing. There aren't any missing, so we've got 1, 5, 3, negative 7, and negative 2. Remember with synthetic, the first term just drops down. We're going to multiply. We get 2. Add downward, that's 7. Multiply, that's 14. Add downward, that's 17. Multiply, that's 34. Add downward, that's 27. Multiply, that's way too big. I'm going to stop right there. It can't be 2. I'm going to go ahead and try negative 2. 1, 5, 3, negative 7, and negative 2. Remember, drop your first term down. That's negative 2. Add downward, 3. Negative 2 would be negative 6. Add downward, that's negative 3. Multiply, that's 6. Add downward, that's negative 1. Multiply, that's 2. Add downward, that's 0. This is what I needed, right? A 0. That tells me that this is a solution because the point 2, negative 2 comma 0 lies on my function. Okay, so one of my roots is negative 2. Now I have this to work with. This is my x cubed. Remember, we started with an x to the 4th. If I divide out an x, I'll be at an x cubed. So this is 1x cubed. This is my x squared. This is my x, and this is my constant. And there's no remainder. You can try factoring by grouping, but I can see factoring by grouping won't work, right? I have an x and then a -1, and I will not have common factors. So I'm going to have to use the rational roots theorem again. Now p is -1 and q is 1. So all of my p to q's are ±1 over 1. That's it. So I get to pick. I can try +1 or I can try -1. I'm going to try +1 and use synthetic division again. This time I'm working with this function though. So 1, 1, -3, -1. Bring my first term down. 1 times 1 is 1, that's 2. 1 times 2 is 2, that's -1. 1 times -1 is -1, that is -2. This is not a root, just like this one was not a root. So I'll try -1. Again, 1, 1, -3, -1. That's -1, that's 0. 0, that's -3. -3, that's 3. That gives me 2. Okay, I must have made an error somewhere. So let me double check. I think I made an error in the beginning. Oh, yeah, I think I made an error in the beginning. So when I tried -2, this gave me 3, -3, -1, 0. Okay, that's true. And so then I had, oh, it's somewhere in here. Okay, so I have 1. Oh, it's right here. You guys have probably been looking at it the whole time. This is a 3 right here. So that's why this wasn't working. I'm not going to start the video over. We're just going to deal with it. So right here, this should have been a 3x. Okay, now my rational roots are still the same, 1 or -1, but my synthetic division was never going to work because I had the wrong function. So I'm going to go over here and try it again. All right, and this should be 1, 3, -3, -1. 1, 3, -3, -1. I'm going to try +1 and see if that's a root. So bring my first term down. 1 times 1 is 1, that's 4. 1 times 4 is 4, that's 1. 1 times 1 is 1, that's 0. The root is x equals 1. All right, now I have a quadratic. Remember I had a cubic. I've just decreased it by 1 degree. So I have x squared plus, I won't mess up this time, 4x plus 1 equals 0. Right, quadratic, linear, constant, no remainder. Now we would check to see if this factors, but it does not. There's nothing that multiplies to 1 and adds to 4. So we have to do the quadratic formula. A is 1, B is 4, and C is 1. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so this is going to be -4 plus or minus 16 minus 4 all over 2. That's -4 plus or minus the square root of 12 all over 2. So this is -4 plus or minus, okay, square root 12 is 4 times 3. Square root of 4 is 2, so that's going to come out. 3 is not a perfect square, so it's going to stay in all over 2. And then they all have a common factor of 2. So this is -2 plus or minus 1 square root 3. And so our 4 roots are, oh, where did my paper go? Our 4 roots are x equals, we had -2, x equals, we have +1, and -2 plus minus square root 3. So -2 plus square root 3 and -2 minus square root 3. And that does confirm this, that we have 1, 2, 3, 4 roots. It's a degree 4 polynomial, so we should have 4 roots. All right, we're going to stop the video there, and we will pick it up on the next video.